So in this video, we are covering chapter 1 of the prescribed textbook, and the chapter is entitled The Information System in Accountant's Perspective. And just a quick warning, please do take this seriously. Okay, now the book lists a number of objectives that the chapter seeks to address. I will not go through each one of them individually, but I would encourage you to do that yourselves, and also do it at the beginning, and then go through the chapter, and then come back and again look at these objectives and convince yourself that actually you have been able to meet these objectives. Now, right from the beginning, we need to appreciate that information is in fact an important resource within a business context. Usually, when people talk about resources, business resources, they're talking about land, capital, labor, raw materials. So you could think of it this way: that the organization takes in raw materials, applies labor to these raw materials, and converts them into some output that the organization then pushes into the external environment. But the organization needs information for it to be able to determine, first of all, what products to produce. How do you decide whether to produce pens or spectacles? And once you've made that determination, you need information that will tell you what raw materials to acquire. You need information that tells you what processes you need in order to transform those raw materials into your finished products. But also you need information that allows you to manage the organization. So information is in fact a critical resource that businesses need to manage. And so as it says here, information is vital to the survival of modern day business organizations. Without information, without a systematic way of managing information, the business would simply collapse. And every day, a huge amount of information will flow to decision makers. Remember your managers, for instance, their main role really is to make decisions. When somebody says, I'm a manager, I manage, you really spend your day making decisions. And for you to make informed decisions, you need good quality information, relevant information, timely information. So vast quantities of information will flow to these decision makers and other users. Other users here, you may be thinking about your design engineers. For instance, they need information for them to be design whatever your company perhaps is manufacturing. But also information will flow from the organization to the outside world. Your firm will have external stakeholders, such as customers, suppliers, and even legal entities to whom you are required to provide reports and other kind of information, perhaps periodically. So information is not only needed within the firm to be able to manage the firm, but also it may be a legal requirement that you provide that information for some government agency. But also you need to provide information to your customers and to your suppliers. So there's information that flows internally within the firm. For instance, your top managers will make decisions about the budget. For them to be able to create those budgets, they need information that comes from the day-to-day operations of your business. So that information that talks about the performance of your organization will go up the hierarchy to the top guys, who will then use that information to create budgets. And those budgets, in fact, are a form of information, and that information then flows down to all the way down to the day-to-day operations, to influence the day-to-day operations of your business. And so the book refers to that as vertical flows of information. That's going downwards. You're talking about instructions and quotas and budgets that come from management, and it is going down through all the levels, even all the way down to the guys who do the day-to-day operations of the firm. But also you have information that flows from that level up, eventually reaching top management. So this is what the book refers to as vertical flows of information, that information may be flowing up or down the hierarchy within the firm. But also within each level, you will have, what the book refers to as horizontal flows of information. So here you're talking about individuals within the same firm who need to share information. And you're talking here about information that is used primarily at the operations level to capture transaction and operations data. So that is information flowing within the organization, vertically up or down, but also horizontally that way. But as we said, you also need to supply information to external stakeholders who may be, for instance, government agencies that require of you that you report periodically. These may be your shareholders, maybe your suppliers and your customers, or even the general public. So as we can see, information is in fact critical to the operation of any business entity, any firm. And here is a nice diagram from this book. And by the way, this is another very useful book that I would encourage you to look at. And here are the external parties that your firm needs to interact with. You are buying, you are buying things from your vendors, you have investors investing funds into your company, you have creditors, you deal with banks, you have customers, you also are dealing with government agencies. But internally also, you have employees and management that you need to supply with information. So all of these boxes indicates where you need to produce and supply good quality information, or where you need to ingest and consume good quality information. So either way, whether the information is flowing in or flowing out, it is critical to your organization. And therefore, as an organization, you need to be able to manage information very well. And to do that, given the volumes of information that you are dealing with, you need some formal system, some formal way of managing that information. And so this takes us now to the idea of an information system. And here are some definitions of what an information system is. And the first one there says an information system is the set of formal procedures by which data are collected, processed into information, and distributed to users. So this actually we will see later when we talk about a system. It's talking about three components, that there should be some way in which you collect data, and then there will be some component that will process that data into information and outcomes information that you can then distribute to users. The second definition here An information system consists of all the components that work together to process data and produce information. Again, as the one before it, the idea here is that there's data that acts as a raw material. We take in the data, we manipulate it in some way, and we produce information. So a system, an information system, is a system that is designed precisely to be able to do that, take in data, process it, and output information. Here's the third definition: interrelated components working together to collect, process, store, and disseminate information to support decision-making, coordination, control, analysis. And now, the first two definitions emphasized the fact that you need data that you're going to process to produce information. This definition goes a little bit beyond that and emphasizes, for instance, that you need a good way for you to be storing your data. So already you can be thinking, oh, we need some kind of database. And also it brings out this idea that the information that you produce from your system is in fact intended to support decision making and management. All of these are really talking about management. So it seems to have a few ideas that perhaps are not particularly well captured by the first two definitions. So in summary then, what are we saying? An information system should be able to take in data, have some way of storing it, be able to process it to produce information that can then be used to support decision making and the general management of your business. So overall, the system is intended to support the stewardship function of management, to support decision making, and to support the firm's day-to-day operations. And it is important, that we always keep in mind that the system does not exist separate from the rest of the organization. It is intended to support ultimately the strategy of the organization. Okay, so those are the things that we need to keep in mind, but maybe stepping back a little now to think about this idea of a system. We talk about an information system, but what is a system? A system, the book defines it as a group of two or more interrelated components or subsystems that serve a common purpose. And the things that we need to keep in mind about a system: one, this idea that it has multiple components. So typically, when we say system, we are not thinking about one object. You are thinking about perhaps two, usually more objects that somehow are related. So the idea of relatedness. And that then serve a common purpose. So yes, they are separate objects, but they are related, and they work together towards some common goal. And yes, we may need to distinguish between a system and a subsystem. Let's look at a few examples, perhaps, to clarify this idea of a system. Think, for instance, here are examples. Okay, all life forms, an atom, the solar system, galaxies, stars, and planets. But let's take a system that we see every day, a human being. So from a distance, we can say, well, that human being is a single entity. But we could, in fact, delve deeper and break that entity into a collection of smaller parts, of smaller subsystems. So for instance, if you're a biologist, you may be talking about the circulatory system, or the respiratory system, or the reproductive system, which are subsystems of this bigger system called a human being. And when you are looking at a subsystem like the circulatory system, yes, it's a subsystem of the bigger system called a human being, but the subsystem also is in fact in a system on its own. So the definition of a system that applies to the bigger system, the human being, also applies to the smaller system, the circulatory system. Okay, so the idea then is that a system is made up of components, yes, that are interrelated, yes, that work towards some common purpose. And when you are thinking about systems like the circulatory system or the respiratory system or the reproductive system, you can in fact quite easily identify that common purpose that the system is working towards. But for some systems, for instance, if we talk about the solar system, the sun and the planets and the planets moving around the sun and each planet perhaps with its own moons, it may be difficult in that context for us to identify the common purpose that the system is intended to achieve. But for the kind of systems that in this course we will be thinking about, we're really thinking about systems that are designed by human beings. And in that case, it is critical that we think about why, to begin with, those systems were designed. What purpose are they intended to serve? So in that case, the common purpose that the system collectively, talking about all the components, that all the components are working towards should be easy to identify. And yes, you can distinguish between systems that are natural and systems that are artificial. And for us, we will mainly be thinking about systems that are artificial. A car, for instance, or a computer, or a computer-based system, or an operating system. So all of those are systems that are designed by human beings, and therefore we can think of them as being artificial. And because they are designed by human beings, we expect that the human being or beings designing such a system would have a common purpose in mind that they want the system to be able to achieve. And so when we go back to our definition of system, that says a group of two or more interrelated components or subsystems that serve a common purpose. For the artificial systems that we will be designing, we expect that the common purpose should be there, we should be able to identify that common purpose. If we can't, then perhaps we are simply wasting resources, time and money, designing something that will not serve us in any way. In studying systems, people often will decompose a system into its components. For instance, when you are studying the circulatory system, you may want to identify the different components that make that make up that system. So, for instance, you may be talking about the heart, so the arteries and the veins and all of that, and be able to understand each component individually. So in studying it, our approach may be reductionist. We start with a big system and we decompose it until we reach a level where we say, okay, these are components that we cannot decompose anymore. And we study that component. And once we understand how each component works on its own, then we bring them together and we try to assemble the system. And hopefully that will then help us understand the system better. we do that because the system is complex. So trying to study it in its entirety might actually be a big challenge for us. But when we do that, we need to remember that the system typically is in fact more than its components. The fact that we know how cells work, the fact that we know how tissues work, the fact that we know how organs work, and those are the things that make up Mary, does not mean that now we understand Mary. We still don't know why she makes the choices that she makes, even though we can say that yes, we understand the cells that make up this particular system. So decomposing a system is useful. It helps us manage complexity, but we shouldn't be fooled into believing that once we understand each component of the system, then when we assemble the system from these components, then automatically we have a complete understanding of the entire system. Because in fact, the system usually is a lot more than the individual components of the system. Okay, so a system is made up of components that hopefully will be working towards a common purpose. Excuse me. And for the system to be able to achieve that common purpose, then it is important that the different components of the system, one, are working effectively, and two, that they are in synergy, that they are in harmonious interaction with each other. So if you have components that are dysfunctional, then the system will not be able to function efficiently. If the components are working, they are working well, but they are not working well together, they are not in synergy, then again the system will not be able to achieve its objectives. So it is not enough that the components be in tip-top condition, working efficiently. It's also important that the components work together in synergy, in harmony, so that now we can say, yes, indeed, this system is made up of components that are working towards a common purpose. So these are things that we need to keep in mind when we are studying and even designing systems. A simple view of a system that's people often use looks like this: that a system exists within some environments, and the system will take inputs from the environment. It will process that input to produce some kind of output that goes back into the environment. So here I probably should have drawn another rectangle here that shows the boundaries of our system. So the system takes input from the environment, does some processing, and produces whatever output it produces. And it's important that a system has this feedback loop. This is called a feedback loop. Because it is important that a system, the system should be able to respond to changes in its external environment. A system that is unable to respond to changes in the environment will quite quickly die. If we go back to our example of a human being as a system, the human being is taking input from the environment, breathing air, drinking water, eating food, processing that to produce perhaps energy, I don't know. But this system called a human being needs to be able to respond to changes in the internal environment. And so, for instance, when it becomes extremely hot, the human being will try to respond to that. For instance, by sweating. And the cooling evaporation of that sweat will then help the system to bring down its temperature. the heat is so much that the, 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 the the body is not able to cope, then it means that the individual, of course, will die. You may still remember this from your primary school science, maybe standard 7B or something like that, where they use the word homeostasis, that the body tries to remain at a temperature of around, if I remember well, 67 degrees Celsius. But for it to do that, it needs to be able to respond to changes in the environment. Sometimes it gets too cold, sometimes too hot. And if it gets too cold, and the body is losing energy, what does it do to try and cope with that change in the environment? The person starts shivering, and that generates energy that hopefully the body will use to try to maintain. So the big idea here, one is that a system takes input from the environment, does processing and produce some kind of output. But also that the system needs to be able to respond to changes in environment. If your system, for instance, is an organization, it needs to be able to respond to changes in the markets, changes perhaps around regulations. If it can't respond to those changes, then it is going to collapse. Okay, here is an example of a system. This comes directly from the prescribed textbook. So the example here is, for instance, a car. That a car is a system. You can think of a car as a single object from a distance. Oh, there is a car. But we can take it apart now and say, well, what components make up this car? And here are some of those components, so those subsystems. So the brake system, that is a component of a car, but it too is a system. It's a system that is a subsystem of the bigger system that we call a car. And you can go in and look at the smaller subsystems that make up this system. And so the brake system will be made up of a number of components that collectively have a common purpose. But when you take now these components collectively, and they will be made, they will constitute a car. So your car is made up of all these systems, and collectively they should have a common purpose. So your system, your car, is a system made up of parts that have a common purpose, and the different components must work in synergy. Hopefully this is a good example that you can relate to. Here is a diagram that comes from a popular management information systems textbook. And at the middle here is our system. So in this case, we are talking specifically about an information system. And so the system takes in inputs, does some processing. In the case of an information system, of course, your input is raw data, and the processing may be arranging or calculating or doing something to the data, and the output comes out, and that output is what we call information. And as you can see, there's a feedback loop that goes back, and that will influence what inputs the system should be taking. So some of the information that comes out will actually be saying to us, we need to collect less of this data and more of that data. Or perhaps the quality of the data that we're collecting is not sufficient. So the feedback allows the system to be able to change. And in this case, you can see the system is embedded within a bigger system that we call an organization. But talking about the organization, you can also think of it as a system that takes in input and produces outputs. And company, for instance, that manufactures pens has some kind of raw inputs that it requires for it to produce its pens. So that input will come in, and manufacturing will manipulate that input to produce the outputs. So the level here depends on your needs. Sometimes you want to focus on the information system. Sometimes you want to step back and think about the organization as a system. Sometimes you want to go down and perhaps look at a computer as a system, and that computer may be part of the bigger system that you refer to as information system. And in this case, of course, the organization has customers and suppliers, and it has to deal with regulatory agencies, it has stockholders, and it must deal with competitors. So that is the idea of a system. And talking about information system, we said it takes in data, it does something, and it produces outputs. And usually when we say data, the distinction between data and information is that data, you are talking about perhaps numbers that do not have a context, and we are going to manipulate them in some way to produce information. Whether it is data or information also depends on the context. For instance, when I am marking your scripts, the information that perhaps I'm looking for, that I need to report to the departmental board, is whether you passed or not. So I need to determine your final mark. And that final mark, for me to be able to compute it, I need to go through and add up the marks from each question. So question 1, you got 20, question 3, you got 10, question 4, you got 15. That's the raw data that I need to manipulate to produce your test score for that particular test. And so the manipulation that I need to do there is to simply add up these numbers, and I will get your 75%. And so we can say, yes, you passed. But sometimes the requirement then would be for me to produce a letter grade. And now the 75% becomes raw data that I need to manipulate to determine whether you got an A or a B. So whether it is data or information will depend on the context. In terms of the functions that one might identify, starting with with the data and ending up with information. There are many ways of thinking about this, but your book identifies 4, let's call them phases: data collection, data processing, data management, and information generation. So data collection is about capturing data. Here we are thinking primarily about transaction data. So we'll talk a bit about transactions later. But for instance, think about what happens when you are buying things from a supermarket. You take your items to the checkout counter. Excuse me, and the assistant scans your items. So by so doing, they're capturing transaction data. That data then goes to some database somewhere. Of course, sometimes you may capture data simply by recording it onto forms, which may be manual paper forms, or it could be forms on a computer screen. And an important thing about idea about data, we need to worry about the quality of the data that our system is taking in, because the quality of that data will determine the quality of information that comes out, and that ultimately will influence the quality of decisions that we make within our organization. So we need to think about validating data to ensure that we have good quality data that we can use to produce good quality information that we can use to produce good quality decisions. Okay, and when thinking about data, we need to think about whether the data is relevant and whether we are collecting it efficiently. If we are collecting data that is relevant, then we are incurring costs unnecessarily. And when I say cost, I'm thinking in terms of direct cost, the cost that goes into acquiring that data. For instance, you are paying people to collect that data, but also you are thinking about opportunity costs. So you need to think about both. But sometimes also one could argue that in some cases it's unethical really to be collecting irrelevant data. Imagine, for instance, that you have a long questionnaire that somebody is filling in, but you know that half of that stuff is relevant. You're not going to use it for anything. So it's unethical that you give me this question and I'm going to spend perhaps 45 minutes answering questions that ultimately are not important to you. So you need to think about your respondents, the person that you're collecting data from, so that you don't waste their time, their effort by collecting data that you're not going to use for anything. So let ensure that you only collect relevant data. Of course, sometimes it may be a challenge to anticipate what will and what will not be relevant. And also nowadays, given that collecting data can be so cheap and storing it also can be so cheap, the tendency is that we just collect data. We take pictures, for instance, with our cell phones, and perhaps you need one picture to send to your friend. Then you take 15 different pictures, and then you sit and select the one that you think is the best, and you send it. But you are reluctant to delete the other 14. In any case, it's cheap. It's cheap to store such data, so you just keep it. And so we have lots of data that this is what people talk about as drowning in data. That we have so much data because it is easy, it is cheap to collect and store data. Sometimes ultimately that data may become useful. Perhaps later on you may be able to analyze the data using, for instance, techniques from machine learning and data science and data mining, and learn something from that data. So in that case, you may ultimately benefit somehow from the data. But you also need to think about efficient data collection procedures. So, for instance, you don't want to be collecting the same data over and over again because of the costs involved. But also because now there are possibilities of inconsistencies. For instance, if at a small university, when a student goes to the library, you collect data about the student. When they go to pay at finance, you collect data about them. When they go to register for a course, you collect data about them. It could be now that the data that we have about this single individual is inconsistent. Sometimes it may simply be small things. That's in the library, this person is called P. Merriweather. In another system, they are called Patrick Merriweather. In yet another system, they are called Patrick Winslow Merriweather. So in the end, it may be difficult for us to tell whether, in fact, in all these cases, we are dealing with a single individual. And so those inconsistencies may mean that we do not derive as much benefit from our data as perhaps we should. So we want to try to avoid redundancy and inconsistency. But redundancy in this context comes across as a bad thing, but redundancy is not always bad. For instance, redundancy, in the context of backups, when you are backing up your data, you are creating a redundant copy. So in that case, redundancy is in fact beneficial. Or for instance, when you are thinking about the system that should be resilient, one way to make it resilient perhaps is to build redundancy into the system. Maybe have several different hard drives that have the same data, so that as when one collapses, the others are still able to run. Or if you think about the internet, for instance, one of the main reasons it is so resilient is because there's so much redundancy built into the system. When some router somewhere dies, well, there are other routers that can take up the load, and the system continues running. So whether redundancy is good or bad will depend on the context, and it is something that as a human being you need to think about. Okay, now phase two, we have the data. What do we do with it? Well, of course, we process it. That is the whole point. We process it so that ultimately we can produce some kind of information. And processing sometimes may be something as simple as sorting. Our raw data may be a list of student heights, and the information that we want is who is the tallest. And so all we need to do is to sort it for us to be able to produce the information that we need. Sometimes, of course, we need to calculate things. Perhaps we have your marks and we want to calculate your GPA, or we have your height and your weight, and we want to calculate your body mass index. So in that case, yes, we are calculating. Sometimes we want to summarize the data that we have. For instance, one way of summarizing our data may be to say, what is the average mark? So we have a list of marks and we say, what is the average? So that is a summary. And so we take in the marks as our raw data. We do some kind of processing to get that average. Sometimes you are comparing, sometimes you are classifying. And so these are the things that we need to keep in mind when we are talking about converting raw data into information. Now, we collect data, and nowadays we are talking about huge amounts of data. So we need to manage that data efficiently. So we need some way for us to be able to store the data so that later on when we need it, we can retrieve it. And earlier we were talking about trying to avoid redundancies and inconsistencies, collecting data efficiently. So that would mean that, to avoid collecting the same data over and over again, when you collect the data and we store it, perhaps in some central location, so that all our users will have access to this data. So if we are going to store it, then we need to be able to efficiently retrieve it. Sometimes, of course, we will need to go in and say, we don't need this anymore, so we can delete it. Or perhaps we want to update things. So effectively, in the context of computer-based information systems, we are talking here about a database management system. I am deliberately saying in the context of computer-based information systems, because if you remember, you can go back and look at the definitions of information system that we looked at, none of them mentioned the word computer. So in other words, you can have an information system that is not computer-based. But even in that case, you may be storing your data in paper files. You want to arrange them so that you can easily retrieve your data. And sometimes you want to remove things, delete things effectively, update things. So whether we are talking about a manual system or a computer-based system, we need these functions. And then, of course, the whole idea, the whole reason that we are collecting the data is so that we can generate information. Okay, so those are the phases that one would go through, and as I said, different authors may identify different steps. It's really up to you to find something that you feel comfortable with. But regardless of all of that, here are important characteristics of useful information that we need to keep in mind. And the word useful here is important, because if these lack, then your information is not going to be useful at all. We've talked about relevance, but and accuracy, because remember, all of these things are intended to support decision making. So we don't want to make poor quality decisions. We don't want to make erroneous decisions. We don't want to conclude, to decide that we should continue producing product B when in fact the market is no longer interested in product B. If the quality of the data that we collect says to us that no, actually the market is still interested in product B, when the market is not interested in product B, it means that we are using inaccurate data, and therefore ultimately the decisions that we make will be problematic. They go through the others. I think you will agree with me that they are quite important. For instance, summaries. Different users within the organization will require different levels of detail. So you need to keep in that. Typically, the top guys, your chief executive officer, for instance, will require highly summarized information, while somebody at the bottom will require the full details. Your chief executive or your top management, they really need something like a dashboard of a car, where at a glance they can look and be able to say, oh, okay, we're okay in this regard and we're struggling in that regard. But of course, they may want to drill in and look at detailed data, so you want to be able to provide that opportunity. But when building systems, you need to understand, of course, your user and their needs, and try to meet those needs. Completeness says, well, is all the information that we need there? If there are things missing, then it means that decision maker will struggle and perhaps ultimately arrive at the decision that will not benefit the firm in any way. Perhaps may even lead to the firm maybe even ultimately collapsing. Okay, but I would also encourage you to read more around this idea of data quality, but particularly, as you think about account information systems, the quality of the data that goes into such a system is critical. It's really, really important.